This is the simulation that was used for the project. You will see in the simulation on the left, the participant had choices to navigate through, including things like size of object, density of object, size of container. In the middle, you can see the participant interacting with the device. They were making their choices, navigating the system, and moving, dragging, and dropping using the Novant Falcon haptic robot. This participant has decided to drop the object and drag the object into the liquid to see what happens. There's another way of viewing what's going on with the simulation with the object and liquid on the right, and you will see that when the participant lifts the object out of the liquid and as the object goes back into the liquid. This participant has moved on to the next scene where now they have choices of size of object as well as density of object. They were also able to choose what forces were activated. However, the forces activated were not fully explained to the participant when they were interacting with the simulation. This participant has visual feedback on, and that's evident by seeing the arrows as they're moving and changing depending upon what the object is doing with the liquid. This participant currently has the largest sized object available chosen, as well as the most dense object chosen. You can see that this participant is dragging and dropping from a higher up distance, seeing what happens as it goes to the bottom. They have a small object now. Letting go of the object from high up was a way of investigating what would happen by dropping an object into the liquid. This participant is also dragging and holding the object under the liquid. And by releasing the button on the Falcon, they were able to let the object go, and sometimes it would sink or float or pop back up to the surface, depending upon the combination that they had chosen. This person now has a medium-sized object chosen and a medium density. You can see over on the right that those spheres are changing depending upon what is happening with the object in the middle. Again, that's just more obvious and more evident to show what is going on between the liquid and the object. This person has moved on to the next scene, and they are choosing between a density of an object and a shape of an object. This person has a medium density object chosen and a sphere chosen for the shape. This person has continued to use both forces, and that's evident by the outline of the box on the arrows in the upper left-hand corner. Those could be turned on and off by switching to just the red force arrow or the blue force arrow, or a combination of both. Again, those forces weren't explicitly told to the participant of what was going on, but they were helpful in showing what was happening between the object and the liquid. You'll see that that blue arrow pops up once it gets into the liquid, and that red arrow is there, both on the object being manipulated as well as the objects on the right side of the screen. This participant now has a low density object and a cube, and now has moved to a light density object and a cube. And they're just seeing what's going on in the liquid when they're dropping it, they're dragging and holding it down, or if they simply let go and the object is able to kind of come to a stop in that liquid. They now have a different density of object and a different density of liquid. They have a medium density object, and they're kind of toggling between a medium density and a high density liquid. Although the liquids and objects were not given a specific example, many times the participants were told that the object is similar to. So if the liquid was similar to gas, similar to water, or similar to oil. Same with the object density, if it was similar to cork, similar to wood, or similar to brick. And they're just seeing what's going on, investigating and exploring the scene. The participant will move on through more scenes like this to add more combinations. While they're doing so, they're getting to experience different pairs of potential objects, densities, shape, size, and so forth. And they're able to make observations with the simulation by using the haptic feedback or visual feedback or a combination of both to really test those different possibilities of pairings.